Hi, today I'll be doing problems on predicate calculus, and these were the problems left undone because of various reasons in my last class, and this will be done, and I will try to do two more problems in this to make you understand better and get a very good idea on this predicate calculus and equip you to do problems of your own. With this, let us go into the subject. So you see that here there is some statement here. Some statement is given here. You must be able to symbolize or express as a mathematical statement. It's not a verbal statement. Verbal statement is given. Let us express it in a mathematical way. A mathematical expression will be given to that. So you see that every computer science student needs a course in mathematics. You must be well aware that any engineering student is supposed to learn mathematics. It may be mathematics 1, 2, numerical methods, or discrete mathematics, probability encoding 3, or random process, any subjects, a mathematics subject like that. Particularly if you are a computer science student, necessary that you must learn discrete mathematics, numerical methods. Okay, so with this, let us take up this first sentence. Every computer science student. So you see that if I take the set of all computer science students as my universe of discourse, that means I take the set of all computer science students. So you see that this is called your universe of discourse. That means for this particular problem number 1, which I am going to express mathematically, giving a mathematical expression like for which I require a domain from which I can pick the elements. So this is a computer science student. So if I say that, I'll write something here, C of x. C of x means C refers to a computer science. It refers to computer science, and X refers to a student in computer science, a computer science and engineering, let us take. So you see that X is a student and E belongs to computer science engineering. So X is a student of CSE, computer science engineering, or even for MCA and BCA also you have this subject. So you can very well say that since we are I'm particularly talking about this engineering students, I take that this X is a student of computer science engineering. Otherwise they can be even BCA students also study this discrete mathematics. Okay, now let us suppose that, let us not go deep into that, it is not required. So you see that X is a student of computer science engineering, and you see that every student who belongs to this must necessarily take a mathematics course. And here let us suppose that discrete mathematics necessary that he must learn. So if I say that for all x, what does that? For all x means every x. Every x, here x refers to a student of computer engineering, and that he is for all x C of x. I put it like this. I put only for this. See, this is a bounded variable. For all x, C of x means for every student, and who is a student of computer science engineering implies that he must take a course in mathematics. MC means what? A course. COUR, a course in mathematics. So you see that I write like this. So you see that now you read this every computer science student needs a course in mathematics. So you see that here x is for all x, c of x, that means x is a student of computer science, and if he is a computer science student, he needs to take a mathematics course. So if he is taking a mathematics course, necessarily he has to be a student of computer science engineering. So this is how you are able to express the first sentence in a what? It is in the verbal form, but in the what mathematical form. We can say that it is an expression mathematically, and we use this for our argument. So this is how we write. Now let us come to the second one. So this is your first one. So you must be, what I insist on this problems is that you must be able to segregate the variables or the different entities that are required to formulate the expression. Are you able to understand? You must know different entities. For example, here you see that computer science student, a student of computer science, that is a different entity, and that mathematical course, it is different. So you must be able to identify them and then connect them through the connectives. So if you can do that, that has to be correctly done. If it is not correctly done, you see that when you take up for argument, your argument will lead to a what? A wrong conclusion. Okay. Now then let us come to this. See, the second one is L of xy means x loves y. L of xy means what? L of xy. So L of xy denotes x loves y, and x and y are, no doubt, they belong to the set of all human beings. So here you see that set of human beings, and your universe of discourse is well understood that it is a set of, it is the set of all human beings. So L of xy means xy is a human being, y is a human being, and x loves y. That is our understanding. Now, so you see that everybody loves z. That means what? For all x, see, this is a quantification. For all x, what is x? X is a person. And L of, I simply write that x, z is also. Now you read that for all x, z is a person and every x loves z. Can you understand? Say what is it? It's very simple. See, for all x means what? For every human being that I take from the universe of discourse, you see that there is one z who is being loved. As I used to say that if sometimes it may so happen that in the colleges some lecturers who are very good or very friendly and teaching is very good or something like that, they will be admired and loved by the students naturally. So you see that there is, for all x is a student and they love a particular faculty, they admire a particular faculty. So in this way also you can think over. So you see that here it is given that x is the father of mother of y. Something is absent here. So you see that x is the father of z and z is the mother of y. That means, how will you write this? How will you write this? Say, I'll write here. So I will put it here. X is the father of z and z is the mother of y. So x is this is a relation. X is the father of z and z in turn is the mother of y. So this must be expressed in the mathematical form, in this what? Predicate form. How will you do that? Now I'll write here. See here x is a person. Try to understand. X is a human being, and whether father, mother or daughter or son, whomsoever it be, they happen to be only what? They happen to be human beings. So you see that there exists, I'll write here, there exists one person x, there exists one person x, and there is one person, x is a person, and there exists a person x, and there exists, what does it mean? There exists a person, x is a person. See here I mean that P of x is a person. See, X is a person, and this X is a father of Z. See, let us take that somebody as Z. See, someone is there. Someone is there for whom X happens to be the father. So you see that I put this relation as X of Z, and everything, because they are connectives. A person is the father of someone. That someone is the mother of someone. So you see that P of X is a person, and this X happens to be the father of Z, and this Z is the mother of someone. So what is that you will write? There exists an X. There exists an X, and this X is a person, and he is the father of some Z, and this Z in turn is the mother of Y. So this is how you write this, the third one. Try to understand that here how this is written. And X is a person. X is taken from the universe of discourse. They are all human beings again. And you see that there exists an X. There exists one person X who happens to be the father of some person Z, and that person Z happens to be the mother of another person Y. So this is the understanding of, this is how these three problems are done. And now let me come to problem. See, I will write this problem on the board and solve. I'll write the problem on the board. In brief, I'll write it in brief, the problem, and then explain to you. So the problem goes like this. See, establish the validity. Establish the validity of the argument. Establish the value of the argument. That is, all integers or rational numbers. NOS means numbers. This is given. And some rational numbers, some integers, here it not rational numbers, some integers. All integers or rational numbers, some integers or power of 3. Say these two are given to you. All integers or rational numbers, some integers are powers of 3. This must imply that some rational numbers are powers of 3. See, this is how some rational numbers are powers of 3. So you see that here it is given that all integers are rational numbers, some integers are powers of 3. These two compound propositions must lead you to the conclusion that there exists some rational numbers which are powers of 3. Now, for that, what you must be able to identify the variables in the predicate form, in the sense that, say I will write here I of x. Let I of x means x is an integer. So this is how you must have. And one more is given, R of x. X is a rational number. And what is the next one? S of x, let me call. X is a number which is power of 3. X is a integer sum, all integers are rational numbers. Establish what is the all integers are, some integers are. So you see that x is a number which is an integer and is a power of 3. Now see, we have identified the rational, we have identified the we have identified the variables. Here you see that we have identified the variables in the predicate form. See, you see that x is an integer, x is a rational number, x is a number which is a, now you have to coin. Now what is that you have to do is, as I have done in my that is statement calculus, you must be able to form the or correctly write the compound proposition. What is that compound proposition? All integers or rational numbers. That means first one is for all x. For all x, I'll write here, it is I of x implies r of x. So what does this mean? For every number you take, if it is a rational number, it has to be an integer. That is I of x implies r of x. And the second one that is given to you, are given only two statements here, two compound propositions. If you can write that properly, then you will be able to complete the problem. Now what does it mean? What does it mean? Some integers are powers of 3. So what is that? Some integers. That means there exists some x, and that I of x and the I of x, and they are integers, and they are powers of 3. See, there exists, see here, all integers are rational numbers. There exists some x. That means what? Here you put it like this. You have to be very careful in writing this. So there exists some x. X is a number, and that x is an integer, and it can be what? And or powers of, and it can be also powers of 3. Now these two statements must lead you to the result that there exists some x which is r of x intersection s of x. That means what? Here what is that you understand by this? You understand that if that is your validity. See, what is the validity of the argument here? You are given that, it is given that all integers are rational numbers, some integers are powers of 3, and therefore some rational numbers are powers of 3. Here I have identified an integer. I write that x is an integer, r of x means x is a rational number, s of x means x is a number which is of power 3. These are the three variables that I require in the predicate form. And then as per the first statement, all x integers, for all x, universal quantification, for all x, I of x implies r of x. If it is a rational number, it has to be an integer. If it's a rational number, it has to be an integer. And then you see that if only condition, I of x implies r of x. And the second one is some integers are powers of 3. That means there exists some x, and that x is an integer and is a power of 3. And now your conclusion must be there exists some x. You actually speaking, put it in the correct form like this. There exists r of x. That means r of x is a rational number, and that it has to be a power of 3. That only some, not all. Okay. Now how to do this? Now I'll rub off this. Now as I have done in the inference theory, I prepared a table. What is that? I prepared an argument table. And I used the laws of inference theory, in the sense that if premise, we call here, you see that these are all premises. These are all called premises. We call them as premises, and using the premises we make an. I have explained elaborately in my last class or even the previous videos also that if you are given the propositions, or in this case you see that your compound propositions in the predicate form. Compound propositions are compound propositions in the predicate form. As I told you in my last video that whatever the laws that you apply for statement, that is propositional calculus, you have to use for what? Here for the for this also, for this predicate calculus also. So you see that all those tautological implications, equivalences, and the algebra of the propositions all hold good. So I'm going to apply here. So in the inference theory, in statement calculus, I told you that two laws, inference law must be used. That is your law of argument. P is, that means what? If I use this P, it means that you are taking up or considering a particular compound proposition as given in the book. And if you write this P rule and T rule, P rule means it is while you do the argument and you prepare the argument table and to infer something, you write, if you write P, that P will denote that it is a compound proposition or a premise being used which is given in the book, which is given in the problem. If I write T, it means that you're arriving at a truth T using the preceding means before, using the preceding premises or the or otherwise means it has got the meaning that you would have arrived at some truth before. So T means a truth which has been arrived at using the preceding compound propositions and applying the rules of logic. Can you get? So apply the rules of logic to the preceding compound propositions and arrive at a particular truth. If you arrive at a particular truth, you write it as T. So that T simply means that your derivation, your correct derivation, I should say that it must be a correct derivation. Okay, if I write P means a premise that is given in the problem. T is a premise that you arrive at which is tautologically true, or it may be an equivalence. Are you able to understand? Okay, now so whatever those I apply, here also I apply the same. Besides these two rules, we have got another set of rules. Suppose you say that for all, this is called your universal quantification. This is called what? Universal quantification. If you are given that universal quantification, I feel that better I will explain what I am going to teach you now while I prepare the table and do the argument. What is that I am going to do? I am going to do an argument keeping these compound propositions. While I do preparing the table, I will explain what are those things that are important to be used in preparing that table. Okay, now I'll write here. See, I'll put it here. So this is your serial number. Many books they put it in some form or other, but everything is the same. I will put it in a simple form, and you can use this and also use any other not a method, any other way of doing it. That means what? All lead to the same results, but the way of expressing is slightly different. So you see that serial number, it is statement, and this is the reason. Now I write 1. See, what is that I write here? I write because I must make an argument. These two are my compound propositions. Use the two compound propositions and try to arrive at this particular result. So this is what I am going to do. This in the statement calculus, plain statements will be given, but unlike those, here all are quantified. Quantified in the sense means we have used for all and also there exists. Okay then. Now let us come to, you can take anything. For example, I will take this for all x. Now you tell me, I have used, since I am going to start my argument with a premise as given in the book. Correct or not? As given in the problem. So you see that what rule should I use here? P rule. P rule means P. P means what is that you understand? P means it is a premise given in the problem. Was simple. P will denote that it is a premise given in the problem. Now I will write something here. Here only I am going to teach you something different which has not been taught and specifically used in this predicate calculus arguments. Okay, while you prepare the predicate argument table, you must necessarily write this step. What does it mean? For all x, what is this? This is true for I of x, r of x. That means for all x, it's all integers, all. If it is a rational number, it has to be an integer. This is as per the problem. Now, this holds good. This particular statement holds good for any variable that you take. Not only for x. It is true for x or y or z, a, b, whatever you take, it is going to hold good. So, what is that you must write? It is I of a implies r of a. That means what? For any arbitrary a, this is true. What is that? For any arbitrary a, this I of a implies r of a is true. Immaterial of what you use, where a or b or c, it is not going to matter. So I of a is equal to r of a. Now what is that you have written here? It is called universal US, you write. What is the meaning of this? Universal specification. This is called your universal specification. What is the meaning of universal specification? Something universal quantifier is given means it is true for all. Now you cannot deal with everything holds good, everything holds good, everything holds good. You cannot say every time like that. You have to take a general case, a specific case and generalize it. For a specific 2 or 3 people you say, and then when you close it or when you finally arrive at the result, say that this is true for all. Okay, so you see that is why we call this as universal specification. So I of a is equal implies r of a is what? It is a universal specification, true for any a. Then we will come to this. What is this? This third one. See third one. What is this? There exists, see I'll write here, there exists I of x conjunction s of x. Now somebody must be able to say what rule should I use. What is the rule that I will use here? The rule is quite very clear that it is P, because it is given in the problem. Therefore I have to use it and know confidently that whatever given in the problem must be taken as true, and with the true hypothesis or true premises given to you, you arrive at certain inferences with the help of what? With the help of the tautological implications, equivalence and other things, that it must also be true. It must also be true. So you see that this is a true statement as per for the argument. This is true because it is given in the problem. Now what is that you will do? Now there exists. Now you tell me there exists. See here I told you that for all x means this a, any a you take, it holds good. And what is this? This a is a number taken from what? Set of all integers. What is that a? The universe of discourse is a. It is a set of all integers. So you see that you are picking elements from the set of all integers. So you see that the set of all integers is your universe of discourse, and you pick elements from this. This particular statement is true, and for any x picked from the universe of discourse, namely that integers. So you see that this is true for all, means for any a you take and put here, that is a true statement. Now coming to this, there exists x, I of x, s of x. That means what? This is also your true statement for some x, not for all. For some x, which is an integer taken from the universe of discourse. So for some means this is for all. For some means even for this a, this holds good. Correct or not? Are you able to catch my argument? This is for all. This is for all. But this particular statement is what? For specific elements. That means what? For the specific elements, this is true. But this a is any random element, because this particular statement is true. So that this can hold good even for that a, because that is true for all. So this is true for that element also. This will be true, because for any element that we have taken. So you see that this fourth one will be, it is I of a intersection s of a. What is the law that you will write here? What is the rule? The rule is existential specification. So this is your existential specification, and this is the truth. This is for any, not for all. Not for all, only for particular element. But this is for all means for this a also this is true, because you are randomly picking. So for that a also this is true, for this is also true, and this is also true. Now coming to the next one, see what is that you get. See, you must understand the subject very well, otherwise if you understand any problem would become easy for you. If there is lack of understanding of the subject, means it will be difficult for you to do. Okay, now fifth one, let us take this I of a. So you see that this I of a, now I'll write that, simply I'll write it as I of a. This is a true statement I take. This is, I arrive at a true value. I say that this is true. How do I say that this is true? Because as per the book, this is true and this is also true. When it is a conjunction, P is true, P intersection Q means P must be true, Q must be true. Both must be true. Otherwise, it cannot be a true statement. So you see that this implies that I of A is true and S of A. This is what? This is true, because what is that you will write? It comes from 4 and it is conjunction. And fifth statement is, it is S of A, and this is also this one, and it comes from the next statement. So you see that this I of A is true. I of A is true. S of A is true, because I of A intersection S of A is true for a particular A. Again I am telling you, it is for a particular A. But this is for what? Even for that particular, this A, same A. Try to understand, same A. Now coming to this, what is that you can say? So you see that I of A is true, S of A is true, and I of A implies R of A. So what is that? I of A implies R of A. That means what? I will write something here. I have taught in statement calculus that if P implies Q and if P is true, what is that? P implies P is true. That means what? Your P statement is true, P implies Q is true, therefore Q must be true. These are all implications. Tautological implications. P is true means P implies Q is true means Q must be true. That is called modus ponens. I told you. I used, this is a law or the tautological law in the statement calculus I taught you. But I told you that whatever law that you are going to use in statement calculus, they can be as well, and confidently you can use in what? Predicate calculus also. So you see that this tells me the same. That means what? I of A implies R of A. I of A is true. That means what? Here I will write R of A is true. R of, how do you get this? This is a true statement. This is the truth that I have arrived at. This is the truth that I have arrived at. How could you do that? I have arrived at using the statements to, let me put like this, because it should have some meaning. Let me put it like this. So you see that it is coming from 2. It is coming from 2. And what is that? It is coming from 2 and which place? And 5. And using what is that? Modus ponens. And what is that modus ponens? P is true, P implies Q is true, implies Q is true. P comma P implies Q. That means Q is also true. So in that way I am able to get that R of A is true. And you must know that this A is only a specific A. Try to understand. This is for all A, but this is for only that particular A also it is true. Therefore here R of A is true. Now I'll write here. What is that you get here now? So R of A is true. Now I'll write here. So now you see that S of A is true, R of A is true. S of A is true and S of A is for a particular A. And this R of A, because of this I of A, it is for a particular A, but this is for all A. So for this also it holds good. So both A you can write, because here for a particular A, but this is for all A. Therefore for this I am writing saying that these two are same A, nothing wrong in that. So you see that this R of A is true for a specific small A, and this S of A is also true for what? A specific A. Therefore as I can write this as R of A conjunction S of A. R of A conjunction S of A. So this is a true statement. This is a true statement that is not given in the book. I have arrived at using, what is that? I use the tautological implication, equivalences, otherwise to arrive at this. So here what is that particular law that I have used in order to arrive at this truth? What is the truth? S of A is true. R of A is true. Therefore, S of A must be true and R of A must also be true. So this comes from 6 and 7. And what is the law that you will use? Conjunction. Are you able to understand? And here again you see that I have not used a special law for arriving in this for predicate calculus. Whatever has been applied, whatever law that could be applied in statement calculus, I am using it. Only thing is difference, its quantification is not that. Okay. Now coming to this, now you tell me. Now there must be somebody who are watching this video, students or anybody must be able to say that this is for what? This A is not for all. This is for a specific A. Can you understand? Specific A means there exists some A for which this is true. What does it mean? There exists some A for which this R of, what is the meaning of R of A? A is a rational number. What is S of A? A is a number which is power of 3. So R of A, so that A is an integer or a number which is rational and also power of 3. Are you able to catch here? So what is that? I am able to get a specific A, not all A. Any specific A, there is some. Not A means not 1. It may be 2, 3, 4. Any number I do not know. So I say that there exists a number A here in this case, which is not only a rational number but also a power of 3. Now this is for what? This is for a few, a selective few. That means you can say that ninth one, there exists some X and this statement is true. So you see that there exists some X which is R of X and S of X. Now you see that this is called what? This is called your existential generalization. Existential G-E-N-E-R. I'll write here, see, G-E-N-E-R S-A-T-I-Y. Generalization. That means what? In all these predicate calculus problems, inference theory, you cannot stop in this here. If you stop in this here, it has no meaning at all. You must quantify them, and that quantification must be properly done. Now here if you write this for all means it is wrong, because it is not for all, it is only for a few. There exists some A for which the truth, what is that you must arrive at? So here I am getting it. There exists some X, which is what? R of X intersection conjunction S of X. That means there exist rational numbers which are also powers of 3. So this is how. And in this particular inference theory argument, it is unlike your statement calculus. Two rules are being brought. One is that if you apply this for all quantification, the next step you can write. You can write universal specification. That means what? This particular statement is true for all values of A. And if it is there exists, then it means that for a specific value of A in that domain, this particular statement is true. You go for doing the argument, make arguments, and you write P and you arrive at T. You do go on doing it unless and until you complete the problem. When you complete the problem, you may come across a step like this in which you cannot stop. That means what? You cannot stop at the finalization, finalize the result. That result has to be converted into what? You must express it as in terms of quantification. Quantification may be what? It may be there exists if it is true for only specific values, and if it is for universal quantification, if that particular statement that you have arrived at is true for all values of the variables. So this is all about this problem. Just go through this. If you have any doubt and if you want any help regarding regarding any doubt or regarding anything that you have doubts or clarification or anything in this, you may write to me. It will be clarified. So, okay. Now this is all about this one. The next problem I will take. So these are all interesting problems that you can do, and there are very many problems. As I told you, you must be able to identify the variables, quantify them, and then do. Okay, because this is a predicate calculus, you must necessarily quantify. Okay, now I will take up another problem. This is, since I have to write this, see. See here, this is very interesting problem is here. See here it is given. Every living thing is a plant or animal. This is what you are given. Every living thing is a plant or animal. John C. or Rom's goldfish is not a plant. Rom's goldfish is not a plant. Rom's goldfish is alive and not a plant. All animals have hearts, therefore goldfish has a heart. So this is what is given. Every living thing, see, every living thing is a plant or animal, and John, say Rom's, here it is Rom's goldfish is alive and not a plant. All animals have hearts, H-A-R-T-S, heart. I'll write it here, H-E-A-R-T, hearts. And therefore the goldfish has a heart. So this is a problem, and we must be able to identify here. See, what is that here given? Now, as I told you, identify the variables in the predicate form, form the compound propositions, do your argument using the preparing the table, and arrive at a conclusion. And here it is given that every living thing is a plant or animal. Ram's goldfish is alive, not a plant. All animals have hearts, therefore goldfish has a heart. So this is, so you have to, these three are your compound propositions. This must lead you to the result, that conclusion that goldfish. So I used to say in my class that compound propositions, you have your compound propositions, they may be the proofs or the statements as given by the witness or the convict. Use them, the lawyer will use them and argue on his side in his own way and arrive at certain inferences. I will not say it is a conclusion. He infers. His inferences, as per him, it is a conclusion. He infers something, and there is another lawyer, you say that he will counter. That means what? A countering lawyer, he will view it in different angle, or he will interpret in different way and arrive at certain inferences of his own, which is his own conclusion. And all these will be given to the a judge, and the judge will analyze everything, and he will he will judge the veracity of the arguments and the proofs and everything, and finally give a conclusion. That conclusion is nothing but the judgment. Okay, so this is, so here is the same thing that we are doing, nothing more. Here we are doing the same thing, and we arrive at certain thing. This is what we have to do now. Every living thing is a plant or animal. So you see that every living, that means what? We take all those things that have got life. I am going to consider all those things that have got life. So I will write here P of X. X is a plant. And A of X, X is an animal. So I want this. It is a plant or animal. And Ram's goldfish is alive and not a plant. So you see that G refers to goldfish. Here it is nothing. Here there is no variable or something. That G means it's a goldfish, and it is a living being. And it is a living being. So you see that I am considering only the living beings. And as per the problem, every living thing is a, that means what? I want to talk about plant. So P of X, X is a plant. And animal means X, A of X, X is an animal. And it is a goldfish that I am taking, so G is a goldfish. And see here now, here I will write here H of X, I will write H of X. That is H of X. Animal, okay, H of X. I want it. All animals have hearts. X has a heart. That is, X is a person. Try to understand that X is a person and X has a heart. So what are those things that I require? P of X, X is a plant. A of X, X is an animal. And it has been talked, something is talked about goldfish also. Someone's goldfish, Rama, Rahima, and we are not bothered. So you see that goldfish, and H of X is what? X. This means X has a heart. Now these are all your what? The variables. The variables. Having found the variables, having identified the variables, now go for coining the compound propositions or premises as given in the problem. Now first one let us take. Let us take the first one. Now every living thing is a plant or an, every means what? All. Every means what? All. That means your quantification must be what? For all X, and here X refers to a living being. So for all X, it must be what? P of X. or you see that this is your or, so it is disjunction A of x. I'll put it here. So the first compound proposition is now read this. You have to read this. For all x, x is a living being. P of x means x is a plant. Or the conjunction means what? Or. So A of x. So this is what he has given in the first one. Then second one. Ram's goldfish is alive and is not a plant. Now what does it mean? What is plant? Plant means you write it as what? P of G. Goldfish is a plant. It is not a plant. P of G means what? Goldfish is a plant. If I put negate it, it is not a plant. Then third one. All animals have hearts. That means what? All animals. See? For all x, h of x. See, for all x, A of x. It means that what? A of x. It means heart of it. Now you read this. For all x. For all x, if it is A of x, it implies that it has a heart. So if that's heart, it must be a living being, and that can also be animal or plant. But as per this statement, this is an animal and it is having a heart. So you see that these are the three compound propositions I have got, and these compound, if you make an argument on this, take this as a premise, take this as a premise, take this as a premise, and place your argument on that, it must lead you to the result that goldfish has a heart. That means what? H of G. What is the meaning of this H of G? So these three must lead you to the result that it must be goldfish has a heart. This is what we are going to do. I hope that you have understood. It is not a difficult one. You have to patiently listen and do problems and practice, so you will get. Now let me start doing this problem. Now you must write the what? The argument table. Even if suppose by chance if you are writing any of these compound propositions wrongly, not as per it does not conform to the statement given in the problem, then you will end up with a wrong answer or you will not get the answer. So your coining the compound propositions must be properly done as per the statements, verbal statement given in the problem. So keep that in your mind. Now let me start doing this. So let me start. So what is that you'll get here? So I'll write here. And you see that x is a plant. I don't want this, I'll rub off this also. Now you see that here, first you take anything that you want. I take this 1. Anything that you want you can take. I will take this. This will be easy for me. I will take this. Now, what is the meaning of this? I have taken this, chosen this as my first compound proposition for argument. This is a premise I have taken. So what is that you will write here? P. What is the meaning of P? It is a given compound proposition. You have taken it to argue on making an argument. Okay. Then next one. So this is for all x. So a of g implies, I straight away take this because g means it's a goldfish. Here it is what? Goldfish. I am mentioning this g as my goldfish. This x is nothing but a living being. Goldfish is after all a living being. This statement is true for all living beings, whether it is a goldfish or whether it is a donkey or monkey or whatever be, snake or anything. This is going to hold good. So this is true for all this. Therefore, this is called your universal specification, and this is 1. I will put it here. Yes, this is universal specification. This is 1. Okay, yeah. So a of g true for all, even for the goldfish, and this is true. Then I will write something here. So I will take this. See, this we will take, and you see that this one I will take for all x. For all x, anything you can take, no problem. P of x, the kind disjunction a of x. This is given to you. This is given to you. So this is also for what? For all x this is true. So you can write this as P of g disjunction a of g, and this is what? Universal specification. What is that? It is coming from 2, 3. So this is also for what? Universal specification. Now I'll write this as, see, it is this is a truth I arrive at from 4 using equivalence. Now you see that, what is that? See here, you know that P implies Q. What is the meaning of this P implies Q? This is identically equal to negation of P disjunction Q. Now I take this. What is that you are having? So here it is what? Negation of P implies A, something like this. Negation of P of G implies A of G. Now this is, if you are going to apply this equivalence, it is negation of P implies Q, then disjunction A of G. So negation of negation is what? Itself. So it is P of S disjunction A of P of G. It is P of G. P of G, I'll write it here. So this is P of G disjunction A of G. So P of G disjunction A of G can be written this form. See, what is that? So that is what I have written here. Now, so I have written something here. So what is that? This is nothing but I have used this and I am arriving at a truth without violating anything. Try to understand. I apply the laws and arrive at a truth. So this is the truth that I arrive at from 4. Now, what is that you have here? Now this means that, okay then. Now let me pause on to the next one. See, what is that you are having now? See, let me rub off this place. I don't want this. Now, what is given here? 5. 6 is negation of P of G. This is given to you. What is that? Negation of PG. See, I have used the first one, I have used third one, I have used. I am going to use the second one. Negation of PG is given to you. So it is given to you. Now, seventh one will be, say, negation of AG is true. What is that? Negation of PG. See, what is I read this? Negation of PG implies AG is true. Negation of PG is true. So this AG of G must be true. I have taught you this. See, I have taught you this, that if P is true and P implies Q is true, then Q is true. Now you see that negation of PG, P of G is true. Negation of PG implies A of G. Therefore, this A of G is true. Correct or not? Seventh one is A of G is true. And it is coming from where? It is coming from the steps. See, it is coming from the steps. What are the steps here? 5 and 6. And using what? Modus ponens. This is modus ponens is this rule. Modus ponens. So you see that we have arrived at. Now coming to the next step, I hope that you should be able to do this. Now what is the meaning of this? So this is your 8th one. Say A of G is true. A of G implies H of G is true. What is that? A of G is true. A of G implies H of G is true. Therefore this H of G is true. Again modus ponens. P is true. P implies Q is true. Q is true. So you see that A of G is true. That is A of G is true. A of G implies H of G. Therefore H of G is true. It is coming from, it is what? 2, 7, and here it is modus ponens. And what is this? This is the result. What is the meaning of this H of G? That means what? G, the goldfish, has a heart. That is what I should prove, and I have done it. So this is my problem. I hope that it should be well understood, because I have given you very elaborately the explanations on those things. Okay, now let us pass on to the last problem here. So I hope that you are able to understand, and if you have any difficulty understanding the subject, or my explanation is a bit hard or something like that, you can write to you can give your comments, and it will be duly attended. Now the last one I will do here. Now what is the next problem is that, see, use indirect method. See, use indirect method to prove the validity. Validity of this one. There exists Y. Yes. See, what is given here is that you have to use your indirect method. I will tell you what is the meaning of. I have specifically taken this problem in order to explain what is the meaning of an indirect method. So you see that here you are given. See, here nothing is no. You do not know what is P of X. You do not know what is Q of X. You do not know nothing you know about this. The only thing that you know is some compound propositions are given, and it is leading to the argument. If you make an argument keeping this premises, it will lead you to some results as what? There exists Z Q of Z. Now I have given you, I have specifically made a mention that you have to use your what? The indirect method. What is the meaning of indirect method? Let us, in the indirect method, the procedure is, assume that the given inference or the conclusion given in the problem is wrong. That means what? It is false. That means what? Here in this particular problem, these two premises will lead you to this, there exists Z Q of Z. Take this as false in the sense that you negate it, take the negative of it, and use the negative statement as your additional premise. That is, in indirect method, I'll write and rub it off. In indirect method, assume the given conclusion is false. And take negation of the conclusion as additional premise. So I have written it very clearly here that in indirect method, assume the given conclusion is false and take negation of the conclusion as additional premise and prepare the argument. That means what? Here assume that what? Assume. So here what is that you will do? Assume this is false. That is, assume there exists Z, Q of Z is false. And so additional premise is negation of there exists Z, Q of Z. Okay, so this is your additional premise. Now you make these. Let us start doing the, see, I have explained everything to you. You will find it easy now. So what is that you will do? Serial number, statement, and know that since you have assumed the wrong thing, something is correct, but you have assumed it to be wrong, therefore you will end up with a contradiction. You will end up with a contradiction. So you see that statement and reason. First one here, let me take this. For all x, P of x implies Q of x. So what is this? This is given to you. This is given to you. And you can see any premise you can take. So what is that you will write? This is a universal quantification. So this is true for all P of implies Q of A, and this is your universal specification, and it is 1. And it is 1. And then what is the next one that you will write? Then there exists, see, third one is there exists y, there exists y, P of y. This is given to you, this is given to you. And the fourth one is you do this specification. So what is that you will write? P of A. This is your existential specification, and it comes from 3. Now you see that this holds good only for a particular A and not for all A. But this A is true for all. So the very same A you can use because this is a specific A. And this is for all A. So the very same A you can take. And what is the next one that you write? So you got this. So P of A is true. P of A implies Q of A is true. So this is Q of A is true. So what is Q of A? This is the truth that I have arrived at. It comes from 2 and 4 modus ponens. Modus ponens. Now you have got this. See, you have taken an additional premise. So what is that? Negation. Additional premise. There exists, see, negation of there exists Z, Q of Z. So this is your additional premise as given P, it is given. So what is that you will write? Negation of this will be for all Z, negation of QZ. So this is what I taught you. When you take the negation of there exists, it is for all Z. And for all Z, negation of QZ. This is for what? This is your, what is that? It is the De Morgan's law. Here you use what? It is coming from this is a truth, and it is coming from what? It is coming from 6, and it is what? It is De Morgan's law. De Morgan's law. And here I will write here. See, what is that I must write here then? I will write it here. Assume. Yes, I will write it here. So or I'll write it here then. And what is the 8th one? 8th one I'll write here. See, this is true for all this one. Universal quantification. So this is true for all. Therefore you can write this as it is coming from 7. This statement is true for all A's. Therefore, for this A also it is true. Therefore, it is negation of this one. So this is true. And now I'll write here, so the ninth one will be, say Q of A is true, we have arrived. And you have arrived also what? Negation of Q is also true. So what I will write here is, Q of A is true, and this conjunction, negation of Q of A is true. And this comes from 5, it is a true statement, it comes from 5 and 8 conjunction. Now what is that I have done here? I am completing the problem. So you see that from this I am able to take this negation inside. So for all Z, negation of Q of Z is true. So this is true for even this A and for this A, the same A. So you see that this is negation of Q of A is true, and this is for what? It is universal. So this is true means what is that? This is true because you are taking the negation inside, and this is a universal quantification, and for that universal quantification you write what? Universal specification. So negation for Q of A must be true. Now you see that here Q of A is found to be true, and this negation of Q of A is also true. Try to understand that this is a true statement. This is true for any A. Therefore for this Q of A also it is true. Therefore this is a true statement, and this is also a true statement. Therefore Q of A in conjunction, negation of Q A is true. That means what? See, P is true, negation P is also true. What does it mean? Both of them true. It is, say, I say that I teach you, I am stand before you, I don't stand before you. Both are contradicting statements. If you take the conjunction, it is a null, it is empty. That means it is false. That means what? This Q of A conjunction, negation of Q of A is true, and it is coming from 5 and 8. This is a conjunction, but this is false, because we know that what? P intersection negation P is what? False. This is false. So I am arriving at what? A false statement. I am arriving at a false statement because I arrive at a false statement because I have assumed the conclusion given to be wrong. Can you understand? And because of the reason that I have taken the conclusion to be wrong, and on placing the arguments I am arriving at a what? A contradiction, and therefore my assumption is wrong. Therefore this implies that what? So this implies our assumption is wrong, and what is the final result? That is, this is correct. That means what? This, that is, for all Z, Q of Z is correct, and this is correct. And here I just make a mention and leave the class. You must know that what is an indirect method. Even in statement calculus, remember that if they give you some compound propositions and say that on placing the arguments on this, you arrive at a particular conclusion, and if you want to prove that conclusion to be conclusion using indirect method, assume that the conclusion is wrong and take negation of that conclusion itself as an additional premise. That means what? You can, while you prepare the argument table, you can utilize this particular negative of negation of the conclusion as an additional premise, and you can go ahead with your argument. But the thing is that when you finally arrive at the conclusion, you will end up with a what? False. That is F. It is what? A wrong. That means what? It is you will end up with F. F means what? It is a contradiction. So since you arrive at a contradiction, your assumption is wrong, and so you can say that the conclusion itself is correct. So this is all about this. We will see more problems and more videos. You will get better, very good number of videos on all subjects you will get. Thank you.